Bismillahirrahmanirrahim. Lecture number first, analysis of algorithm. The recommended book for this course is Common Second Edition, Introduction to Algorithms. So I recommend this book to learn the subject in details, and I will try my best to solve some problems from the same book and solve some exercises from the same books and its relevant chapter. The chapter number 1 is about the role of algorithms in computing. So in this chapter, students will learn about the importance of algorithm and why algorithms, and the most important thing is it's very much important for solving problems which may need the programmer's attentions. So chapter number 1, algorithms, and algorithms as a technology. So we will study these two topics today. It's an overview of algorithms and their place in modern computing system. So we will study about algorithms and where we can apply the algorithms in modern computing systems. I mean in software development and in different industries. This chapter defines what an algorithm is and lists some examples. And it will also makes a case that algorithms are as a technology just as our fast hardware, graphical user interface, object-oriented systems, and networks. So let's define it formally. Actually, algorithm it's a function, and we provide input to that algorithm, and it produces output. So let me give you a simple example over here. The example is, for example, we have a juicer, okay, and in that juicer we put some banana, okay, and after that we put some sugar, okay, and we put some milk, etc. And you can see here these all are the inputs, okay, and by itself this juicer is the algorithm, and it produces us the output, and the output may be a glass of a glass of milkshake. So you can see here this is the output. So it means that an algorithm is any well-defined computational procedure that takes some value or set of values. The value may be single or the value may be multiple as input, okay, and then algorithm performs some procedures over those inputs and produce value or set of values as output, okay. So that is the definition of algorithm. It's a kind of informal definition. I'll study some other definitions. A computer algorithm is a detailed step-by-step method for solving a problem by using a computer. So this is another definition, okay. Second one, an algorithm is a sequence of unambiguous instructions for solving a problem in a finite amount of time. This is very important. This is the important definition. Well, you write an algorithm and it has, for example, 4, 5, 6, 7 steps, and it's you, okay, and it's me. For example, I am writing an algorithm and it has, for example, these much steps, okay. The problem is the same. We have the same problem, okay. The problem is the same. For the same problem we write algorithms. You write your own algorithm, I write my own algorithm, okay. So how much time your algorithm takes and how much time my algorithm takes, so we call it time complexity or execution time of any algorithm, okay. So in definition it's clearly mentioned that it must take finite time, otherwise your algorithm is not you can say suitable algorithm, okay. The third definition is an algorithm is thus a sequence of computational steps that transform the input into the output. As you seen in the previous slides, you provide input to an algorithm and algorithm produces the output, okay. Let's move Further, we can also view an algorithm as a tool for solving a well-specified computational problems. So what kind of problems? May be computational problems, those problems which needs the attentions of computer. Through computer you can solve problems, so we can say such problems are called computational problems. Or you can see that when there may be some computation required in some specific problems. For example, ATM machine, how ATM machine produce the money, and how it counts the balance, etc. So all it's written, it's a kind of computational problem. Well, the statement of the problem specifies in general terms the desired input-output relationships. It's another important aspect of an algorithm, that you provide input, but the input must be relevant to the output. There must be a relationship between the input and output. For example, we write an algorithm which produce, for example, for our air ticket system or railway ticket system. So we need to provide the the desired input. For example, the name of the passenger, the age of the passenger, the destination, etc. So that algorithm will provide the same result as we want, for example, in the form of its ticket. So the algorithm describe a specific computational procedure for achieving their input-output relationship. So it means that there must be a relationship between inputs and outputs, and it's the job of an algorithm to do that. Okay. Let's have an example of a computational problem, the sorting problem. You know that in computer science, in computer, this is the most important problems being discussed in any algorithm subject. Here is the method for solving sorting problems. For example, we produce input a sequence of n numbers, a1 to an, for example, from 1 to 10 numbers, and the algorithm produce output, means it's produce the a permutation, reordering of the given inputs of the input sequence, such as a1 less than or equal to a2, a2 less than or equal to a3, and so on. For example, 1 2 3 4 5 6. It means that the sequence being provided, it was in unordered form, and after performing the sorting algorithm perform its procedures over those inputs, and that algorithm provides the data in sorting order, in reordering shape. For example, given the input sequence 31 41 59 26 41 58, so it's input. Okay, this is the example of input, and a sorting algorithm returns as output the sequence 26 31. It means that it's order. Such an input sequence is called an instance of the sorting problem. It means that the produced result, it's called the instance of that algorithm or the sorting problem. Okay. Factors for a best algorithm. So what factors must be considered for a best algorithm? When you write your own algorithm, so you need to consider these factors. Following are the factor the best sorting algorithm, and it's basically written for the sorting algorithm. Okay, so the number of items to be sorted. Okay, this is very important when you are working on a sorting algorithm. So you need to know about the number of items, the input, the size of the inputs. It's very important. For example, you're going to sort 10 numbers or 100 numbers, okay, or 200 or 1000 numbers, depends upon your size. Okay, possible restrictions on item values. Okay, this is another important factor we must consider. Possible restrictions, a kind of validation we need to apply on inputs. Okay, and the kind of storage device to be used, main memory, disk, or tapes. This is also important. Okay, the data you provide as an input. So how much RAM will be utilized? Your input will utilize the RAM size. How much will be the hard disk size? Okay, and maybe the tape memory. So tab storage, so how it occupy the space. In short, let me tell you, if your number of inputs is more, it will utilize more space. If the number of inputs is less, it will take less space. Okay, so in algorithm, two things are very important you need to keep in mind. One is the time complexity, the second one is the space complexity. Okay, how much space your algorithm takes and how much time to execute. Okay, let's go further. Correct and incorrect algorithms. Very clear answer. An algorithm is said to be correct if for every input instance it halts with the correct outputs. Very important. You provide inputs and it provides correct outputs. We call it correct algorithm. And incorrect, it's opposite. We say that a correct algorithm solves the given computational problems, and incorrect is its opposite. You provide the inputs instance, and maybe some inputs don't provide the desired output, so we can say it's called incorrect algorithm. Okay, move on. Incorrect algorithms can sometimes be useful if their error rates can be controlled. So exactly. Ordinarily, however, we shall be concerned only with correct algorithms. In these subjects, we will work upon some correct algorithms. Okay. Algorithm specification. An algorithm can be specified in English as a computer program. Keep in mind, in the question is about how to write an algorithm, so you need to use the English human language or even as a hardware design. Okay, algorithm can be specified in English as a computer program or even as a hardware design. So according to your hardware design, you need to write the algorithms. It means that you write an algorithm A and you want to apply it on two computers. Okay, so how this computer deals with algorithm A and how this computer deals with algorithm A, so depends upon your hardware design. Its speed, it's, for example, it's a very good computer and it's a less good computer, so both will have the same algorithm differently. The only requirement is that the specification must provide a precise description of the computational procedure to be followed. It's very important. Whenever you are writing an algorithm, you must specify that on this PC it will take this much time, on this PC with this specification it will take it will deal like with that hardware like this. So you need to specify during writing an algorithm. What kind of problems are solved by algorithms? So it's a very in short, let me tell you, the Human Genome Project, it's a project, has the goals of identifying all the 1 lakh genes in human DNA, determining the sequence of the 3 billion chemical base pairs that makes up human DNA, storing this information in database, and developing tools for data analysis. Each of these steps requires sophisticated algorithms, and it saves time and money. In short, let me tell you, the number of these genes are very you can say it's a large number. So like using your mind or piece of paper or pen, you cannot solve such problems, so you need to have an algorithm for solving such problems. And let me tell you, these days, for example, how the coronavirus spreads inside a human body. So we can say that it may spreads in billions, in trillions, in seconds. Even the time is also considered, and also its size of spreading. So such kind of counting may be possible with the help of algorithms. Okay, to access and retrieve large amounts of information from internet, clever algorithms are employed to do so. You know that we are using internet, large amount of data on daily basis, video, audio, images may be uploaded. The best example is Facebook. Okay, google.com. So the search engines, okay, I mean in text form of data, symbolic form of data. So it's large amount of data daily, on daily basis we can see on internet. So this is the clever algorithms, the YouTube algorithms you can see here. It's another example of algorithms, okay. For electronic commerce, you know that these days we are using digital currency in the shape of bitcoins or Paracoin or OneCoin, etc. So these kind of systems, I mean the blockchains, it uses the best algorithms, okay. And you know that the transactions, for example Alibaba.com, the Amazon.com, such websites use the clever algorithms, okay. And these algorithms keeps the ability to keep information such as credit card numbers, passwords, and bank statements private is essential if electronic commerce is to be best, you know, used widely. You know that people were not believing before such algorithms, and now you can see here everything is online, the businesses or trades are online. So it's because of clever algorithms, okay. And the best example is the public key cryptography, and digital signatures are based on numerical algorithms and number of theories. It means that this is the best example. So you will see this topic in the e-commerce subject, public key cryptography. It's a kind of information I'm sending in the middle, it's become encrypted. The algorithms makes such information encrypted, and on receiver end it may be received in the you can say here in the safest form, okay. Move on. In manufacturing and other commercial settings, it is often important to allocate scarce resources in the most beneficial way. Finding shortest route on a graph or a roadmap, finding the multiplication of n matrices. So many uses of algorithms are here. I recommend the book, go and there watch, okay. What is data structure, okay. Before understanding or writing in any algorithm, the writing steps of any algorithms, we must know about the data structure. It's a kind of way to store and organize data. In order to organize data where? In your computer, okay, in computer memory, okay, how your data look there. In order to facilitate access and modifications, why we organize data inside computer memory? Because the users do accessing, and the user also modify the data accordingly. No single data structure works well for all purposes, and so it is important to know the strengths and limitations of several of them. So very important. Data structure is a subject by itself, and the computer science students must study these subjects as well, okay. Move on. What kind of problems may be solved by algorithms? Keep in mind there are some problems, however, for which no efficient solution is known, and we call such problems hard problems, which are known as NP complete, okay, or hard problems, okay. These problems may not be solved with the help of algorithms, okay. Well guys, algorithm is a technology, okay. Keep in mind here I would like to discuss a bit history of algorithm, okay. The Muslim mathematician Muhammad bin Musa al-Khwarizmi brought this word algorithm, al-Khwarizmi, algorithms, okay. And he says that no problem will be solved if there are no steps, prior steps defined for solving the same problem. So we must solve a problem with the help of those steps. So this is these are the sayings of that great man, great mathematician Muhammad bin Musa al-Khwarizmi, okay, and who brought this subject to us. And you know that all computer science is now based on this, all technology is based on this, you can say. So that's why algorithm as a technology we must consider algorithm as a technology. Suppose computers were infinitely fast and computer memory was free, would you have any reason to study algorithms? The answer is yes. Algorithm is needed anytime, everywhere, okay. Because if we say computer is algorithm, it's true. Computer by itself is algorithm, It's true. Every technology based on algorithms, so hence prove algorithm is a technology and it is a tool to solve any computational problems. Hence prove that algorithm by itself is a technology. Okay, and you can see here hardware with the high clock rates, pipelining and superscalar architectures. Okay, must need algorithm, easy to use, intuitive graphical user interface. For that algorithms is required. Object oriented systems, C++, Java need algorithms. Local area and wide area networking, and networking side you can see algorithm is there. Real time system, you can say here for example the air traffic control, railways and so many more. So algorithm is a technology. Okay, efficiency of algorithm, which algorithm may be called efficient algorithm. Okay, so we have two examples here. Okay, actually this algorithm takes 2000 seconds, okay, on computer A. The same algorithm takes 100 seconds on computer B. So it means that if we say an algorithm is efficient but after applying on two different hardware, okay, so that's why we can say this algorithm is efficient. In this case this algorithm is efficient. Okay, it's a case study, and I request you to read it out. But in short, for a concrete example, let us pit a faster computer A running insertion sort against a slower computer B running merge sort. Okay, so both are different computers. Okay, this computer is A and this is B. This is fast computer and it is the insertion sort algorithms. Two different algorithms are applied over there. One is the insertion sort and this is slower PC computer, and the merge sort, okay, is running over there. So depend upon your algorithms. Okay, well, in short, if you read all these things it's okay, but let me tell you at the end, the computer is fast by itself but it's running a slower algorithm as compared to the faster algorithm, and that is the merge sort algorithm. It's faster, that's why the computer is slower, but the algorithm by itself is fast. So that's why it takes less time and it takes more time. So it means that in this sense an algorithm may be called efficient algorithm if it takes less time on a slower PC. Okay guys, what properties must be considered while writing an algorithm? Keep in mind input, okay, output, finiteness. It means you must write steps up to, for example, 10, mean that the steps must be known. Okay, effectiveness, the algorithms you write, it must be effective, efficient and elegant, concise and compact. These properties must be considered while writing any type of algorithm. In this subject actually we are studying this topic, it's called the analysis of algorithm. Okay, so whenever you write an algorithm, so after analysis we find how much time it takes and how much space it will occupy inside your computer memory. So that's why we call it analysis or analyzing an algorithm. In order to design good algorithms, we must first agree the criteria for measuring algorithms. We will measure algorithms in terms of the amount of computational resources, okay, that the algorithm requires. Okay, keep in mind, For every task you must require some resources. So here resources may be your the input resource from where you take the inputs, your hardware resource. And practice, there are many issues that to be considered in the design of algorithms. The ease of debugging and maintaining. It means that when you are writing an algorithm, you must face problems. Okay, you must face some anomalies, some errors. So you need to work upon debugging and maintaining of the same algorithms, and it's a kind of best programming or best algorithms practice, that you know how to debug an algorithm, how to remove errors from that algorithm. Concern with prediction of resources used by the algorithms for its characterization, performance, efficiency, adequacy. Keep in mind these four concern with prediction of resources used by the algorithm for its, why we use the resources you're utilizing, but you must keep in mind that I want to get these characteristics to measure two major measures, the time and the space. Okay, and why we write algorithms? We write algorithms for this purpose. Okay, characterization, performance, efficiency, adequacy, and also time and space. Why analyze? I mean, the analysis is important, but why? The most straightforward reason for analyzing algorithm is to discover its characteristics in order to evaluate its suitability for various applications, comparisons. That's why analysis. It means that actually we compare, for example, the insertion sort. Okay, the insertion sort, I mean the sorting algorithms. For the sorting, this is the insertion sort algorithm, and the one is, for example, quick sort algorithm. Now we compare quick sort algorithm. Okay, so we compare both algorithms. That's why we do some analysis, how we could find that this algorithm is best and this is not best. Okay, this is, for example, not best, not efficient, for example. So how we will say like this after analysis, right? So we do that, how we analyze an algorithm. In next chapter you will see that. And at the end of the chapter, thank you so much, students. Please subscribe my channel for more videos. Thank you.